Good morning, boys and girls. This is Mr. Ho talking about permutations, which is a question similar to supplementary exercise 4, number 19. Well, this one, we have a remedial class of 5 boys and 5 girls. John and Mary are among 2 of them. So, of course, John is a boy, Mary is a girl, okay? Don't tell me otherwise. So they sit in a row. Find the number of ways that they can be seated if there is no restriction. Well, no restriction. 2 rows. Oh, sorry, 1 row. 1 row, okay? So, well, we just arrange 10 of them. So part A, I don't write down complicated sentence. Part A's answer is simply 10 factorial. Okay? So what is 10 factorial? You can use your calculator. So let me calculate this. My calculator has no factorial function. So I have to calculate that one by one. Okay. Yes, 10 factorial is 3628800. Okay. You can calculate faster than me because your calculator probably has the factorial function. And then, now part B. Boys and girls have to sit alternately. This is an interesting part. Now, must learn this question because this is very common type of problem. Now, suppose we have the boys sit first. Okay? So we have boys, now the boys, right? These are the boys. Sit first. Then these 5 boys, the number of permutation will be 5 factorial. And then since boys and girls have to sit alternately, the 5 girls must either sit arranged here, okay? So 5 girls must sit among here, so we have another 5 factorial. Or, now looks like it is or. Now, alternatively, the 5 boys sit among here, same as before, but the girls sit among here. Then they will sit alternately. And therefore, another 5 factorial appears. So it's 5 factorial times 5 factorial times 2. So 5 factorial is 120, yes, and then times another 120, which gives 14400, and then times 2, so the answer is 28800. Now, Mary and John must sit next to each other. If we are required such that Mary and John must sit next to each other, Mary and John must sit next to each other. So let's say order 10 seats. 4, 5, 6, 7. Oh, have I missed out? We have 3 more 10 seats. Now, Mary and John, suppose they are bundled together, okay? Tied together. Okay, so they can be considered as one piece. And therefore, all the other classmates can sit whatever we like. So they're treated almost as if there are only 9 objects. Right? This is John, this is Mary. They are bundled together. So all the rest, okay, count that, okay? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Since 2 of them are bundled together, we have only 9 choices to arrange them. So the answer is 9 factorial. If John is sit first and then Mary sit next to him, to the right of him. However, we can also think about Mary sitting first and then John sit to the right of him. So there is a multiple of that. Okay? And therefore, it's 9 factorial times 2, which is, again, my calculator doesn't work, okay, times 2, which is equals to 725760. Now, part D. John and Mary must not sit next to each other. The opposite of John and Mary must not sit next to each other is must sit next to each other. And therefore, the required number is part A's answer when there are no restrictions minus they must not sit next to each other. Minus they must sit next to each other. Well, just use our calculator. So what does the calculator gives us? So it is equal to minus this one. The calculator gives us this answer, right? 2903040. Okay, to get the same answer? Yeah, should be. Okay, so that is it.